Welcome to this KuppingerCole Analyst chat. I'm your host. My name is Matthias. I'm Senior Analyst and Lead Advisor with KuppingerCole Analysts. My guest today is Alexei Balaganski. He is a lead analyst with KuppingerCole, working in his area of expertise, which is cybersecurity. Hi, Alexei. Good to see you.
Hello, Matthias. Thanks for having me again.
We want to have a look at a topic that we've covered in earlier episodes already. We want to have a look at how we should and can do cybersecurity more properly, more adequately in a world of changed communication that we are seeing right now. And this is really reflected in the way we do business, in the way we work as of today. We are no longer relying, and that has been said so many times, on a perimeter-based security, so that we have the organization, the company, with a firewall around that and a secure inside and an insecure outside. We are now working from home, from everywhere in the world, and every communication is under attack, is endangered, is taking place in a hostile world. So no longer a perimeter. How can we do business? How can we do security in such a world, Alexei?
Yes, Matthias, you're absolutely right. This whole idea that our IT infrastructures are losing their perimeters. I mean, it's definitely not new. I think it started nearly 20 years ago. This whole notion of deperimeterization was already discussed before we had clouds, before we had zero trusts and blockchains and other stuff. Even back then, people hadn't realized that this idea that you build basically a castle with a wall and the moat, and you keep everything sensitive inside that castle and hope that nobody breaches your wall. I mean, this idea was not sustainable back then. It absolutely doesn't work anymore nowadays, simply because we don't have those castles anymore. We have no perimeters. We live in the cloud or in multiple clouds. We have people working from home. We have IoT fleets. We have connected vehicles and manufacturing plants and multiple data centers. It just, your IT doesn't even belong to you anymore because you probably rent huge parts of it. So that's just that one idea. There is no perimeter anymore. A slightly related idea, but fewer people think about, is the overall increase in complexity. The problem is that complexity does not increase linearly. It actually grows exponentially. If you get, let's say, 10 times more computing devices in your network, the complexity doesn't grow 10 times. Perhaps it grows hundreds of times, if not thousands, because all those devices have to communicate with each other. They have to communicate with external people, devices, identities, whatever. So you have to deal with, like in a corporate network of a reasonably large enterprise, you probably have to deal with hundreds of millions of potential connections. And by far, the majority of those aren't even necessary. They're just additional opportunities for a potential hacker to get inside your enterprise. And this is exactly why we are talking about this interesting notion that zero trust means zero blind spots. Basically, you have to know what's going on in your network, right? You have to keep an eye, ideally, on all of those connections. The problem is that you cannot. It just does not scale. If you just say, okay, I will have my SOC, I will have a team of experts watching every connection, every device, and I will have absolutely full visibility into all those millions of connections, then I will definitely stay on top of the hackers. No, you won't. Just you have way too much information, and again, 99.99% of those is simply unnecessary. And we have to reconsider and find an alternative approach to it. This is exactly what we are going to discuss today, right?
Exactly. And the first approach to achieving cybersecurity actually was to segment to have a segment that really represents the safe harbor, the safe organization, the premises of an organization, to make sure that everything that is inside is considered to be trusted, everything that is outside is considered to be hostile, and that needs to be controlled. And there was a ring fence that made sure that there was a clear line between inside and outside that could be inspected, and every connection into this perimeter and out of this perimeter could be inspected. But that was just a starting point, right?
Right. Well, as you just mentioned, kind of the original way to segment your networks was just to have one segment, the LAN, right? And everything else was untrusted. And everything inside the LAN was implicitly trusted. It didn't work even back then. Now we don't even have a LAN anymore because we are working from home, for example, still, unfortunately. Then people decided that maybe we have to configure an additional segment, a DMZ, where we would place some of our important resources which have to be accessed from the outside without actually giving full access to the LAN. I mean, again, even 20 years ago, it wasn't really that particularly flexible. Nowadays, it just doesn't work anymore. Then came this idea of doing a logical segmentation, if you will. First, it was based on purely on VLANs and virtual networks and routers. Then came the firewalls. So basically, people tried to find the way to build kind of tiny walls within your castle to separate one department or one part of the data center, one specific application subnet from the other, to keep those unnecessary connections under control, right? So if you only have, let's say, one single firewall and you have to channel all your external traffic to a sensitive application to that firewall, that dramatically reduces the potential attack surface. On the other hand, this approach alone kind of gets out of control quickly, because nowadays large companies might have tens of thousands of firewalls. Of course, not all those firewalls are physical devices anymore. They're probably virtual, containerized, cloud-based, but you still have to manage them. And when you have a complicated additional infrastructure, you only need it for security, and you cannot even manage that infrastructure alone. Well, what's the point of it? It doesn't actually add anything to the overall security.
Exactly, and this is especially true as the way we are doing our work on a daily basis has dramatically changed, and we don't always have to talk about the pandemic. This way of working has changed before, and we are moving towards working from nicer places than at home or the office. We think of working from cyber cafes somewhere close to the sea or something like that. And we also want to be safe and secure in such an environment. So we would like to consider ourselves being in a situation where we know that the systems that we're communicating with are secure and that they are communicating safely, but also we, as we are users in that cyber cafe, in that co-working space, can consider ourselves as being protected, as our devices being safe, and communicating encrypted and securely with our target systems, be they in the cloud, be they still on-prem if this exists anymore. And this communication also needs to be well protected. So us being in a safe bubble and the systems being in a safe bubble, that is much closer to reality right now.
Well, what you have just described does suspiciously sound like zero trust, doesn't it? Because you just mentioned instead of having one large perimeter around the whole network, you just build a tiny perimeter around each device, each user, and so on. That's exactly like the primary principle of any zero trust architecture. That access controls to anything has to be per resource and per session. So in fact, even before going into technical details of potential implementation, we can see that zero trust is exactly kind of the right approach to actually logically segment your network in a way which was previously impossible, because again, where you would have to deploy hundreds of thousands of firewalls and then manage them somehow manually, probably. Now you would probably have like a tiny built-in firewall around every resource and application and device. Again, there is more than one way to actually implement it. We discussed technical details in many publications we have on our website, in webinars. So basically, there is always more than one way to actually design a zero trust architecture. And in a real life scenario, you probably need a combination of all of those. My point here is that regardless of how you approach it from a technical perspective, logically, it's all about segmenting your network access to the point that each object on that network lives in its own segment. And that alone guarantees that there are no more potentially open, unnecessary ways to communicate between different resources we do not actually need to communicate. Because your zero trust architecture is designed on that another foundational principle: default deny. Don't trust anyone, always verify. So if you had a flat network with 100 devices and probably like 10,000 of potential communication paths, now you would only have 100 devices, each with a tiny micro segment around. You would only have maybe 10 or 20 open paths because all the rest is closed by default. And this is exactly, again, kind of goes back to this idea. Zero trust means zero blind spots. There are many ways to approach visibility. Security analytics, XDR, EDR, whatever. And the only kind of real future-proof and proactive way to ensure visibility is not to see everything. It's to ensure that nothing which isn't worthy to be seen even exists anymore, right? And this is exactly the point of zero trust.
Well, this is interesting because that sounds like we are introducing the principle of least disclosure also into the way we protect our security, our systems, our communication. So we only let out the information that is actually relevant, and this we keep as secure as possible and as authenticated as possible. But everything that is not of importance, and on the other hand, could even be dangerous to disclose, is left out, is hidden, is omitted from communication in general. So the only thing that we need to make sure is that we decide what is important, what not. Which communication is secure, and where we can identify where communication is safe, where users are legitimate, where authentication is ensured, where encryption is safe, and communication is possible, right?
Well, again, if we kind of go back to one of our previous episodes about the principles of zero trust, one of those core principles is that you have to separate policy management and policy enforcement, meaning that you only have one single place where you define the rules, who or what can connect to what, and how and when, and all other aspects. And then this policy should apply regardless where it's located, whether it's a SaaS application or an IoT device or a mobile phone or a legacy computer in your basement. Ideally, it should work the same way everywhere. Unfortunately, I believe we are not quite there yet, but at least we have solutions which kind of already can scale or for thousands or tens of thousands of kind of devices protected by the same way, if you will. And again, there might be like application microsegmentation solutions, which are basically tiny firewalls, virtual firewalls, or maybe even built-in firewalls, which every Windows machine or Mac or Linux server have, along with a separate control plane, which actually manages and monitors all of those firewalls and distributes policies. And again, if you have this platform which just knows how to talk to one firewall, quickly and efficiently, it can automatically talk to 10,000 of firewalls and orchestrate their communications, or actually kind of prevent the unnecessary ones. Unfortunately, as I mentioned, we have such solutions implemented as quote-unquote traditional microsegmentation technology. We have SDP, the software-defined perimeter, which basically does the same, but through a different technology. So instead of a firewall, you actually have a point-to-point encrypted connection. But it's basically, it boils down to the same thing, allowing access to a resource securely and only on the kind of need-to-know basis. You can only access what you are allowed to explicitly. There are some other approaches. For example, the Google Beyond Corp is based basically on a slightly more sophisticated web access management, so-called identity-aware proxy, which is basically either allows you to access a web app based on an access token or not. So there are multiple technologies. The only kind of missing link is our control plane, which could orchestrate all of those together. So we are not there yet, but at least we are one step closer to the goal, because we have more than one way to implement it.
So that sounds really like a concept, like a technology plus a concept that really is forward-looking, and that maybe also our audience wants to focus on, to understand more, to learn more. What would be technologies and concepts and documentation to look at when it comes to moving forward in the right direction to improve this visibility, as you said, and to reduce this disclosure of data, and to make sure that you are on the right track moving towards zero trust done right? What would you recommend here?
Well, again, I would like to emphasize that regardless of which technology you choose, and again, you probably have to use more than one, visibility comes at no extra price. The whole idea that instead of maintaining visibility by kind of taking an effort and looking everywhere, which you do now with traditional tools like SIEMs and XDRs, you are only allowing things that matter. And by kind of having explicit control over them, you automatically know about them. So basically, you only see what's necessary, and you don't even bother looking for things which aren't necessary. And that alone saves you probably 99% of the administrative and monitoring and forensic effort, if you will. So the great thing about zero trust is that by eliminating implicit trust, you are eliminating the need of implicit visibility, if you will. But back to your question, if you actually want to know more about specific technologies, of course, you can start on our website, maybe, because we have a lot of publications on zero trust. We have webinars covering specific technologies and even vendors. We are definitely working on leadership compass reports in this area. So there's a lot of things to learn at KuppingerCole.com. But of course, I mean, zero trust is such a major buzzword nowadays. You can find lots of information around. You have to know what to look for. Again, kind of explicit visibility, I believe, is one of those hidden gems of zero trust, which not many people talk about.
Really interesting. And this is really also something that I took away from our today's session. This is really something that I learned from you today. This visibility, and to make the right steps towards that is really an important step. So a great summary also from your side to summarize this overall topic, which has a lot of complexity in itself, but doing things right and having a grasp of the bigger picture really is of importance. Thank you very much, Alexei. Some final words from your side before we close down?
Yeah, you're absolutely right. Kind of, it might even sound kind of counterintuitive, but with zero trust, you are actually massively reducing complexity and massively reducing the administrative effort. Not just because you are kind of eliminating the duplicated infrastructures and stuff like that, or unnecessary security tools, but because you are centralizing management and visibility. And that alone will probably, your security teams will thank you for that more than anything else.
Yes, that really sounds interesting and promising. Reducing complexity, improving security through technology and its orchestration. That is really a way to move forward. Thanks again for that summary and for your insights here, Alexei. Thanks for being my guest today. And I'm looking forward to having you in an upcoming episode very soon.
Thank you and goodbye.